Differentiation 1, Rule 2, Product Rule. So in the product rule, what we're going to be asked to do is find the derivative of the product of two different functions. So we can, of course, multiply out the brackets and differentiate as normal. Or if we go to page 25 of our maths tables, as we can see up here in the top right-hand corner, what you'll actually see is a rule that deals with products where we have two functions multiplied by each other. And this is useful when the products are quite complex. So what you can see here is when we have the product rule, we have y equals u times v. So what they're saying is the first part of the product should be called u. So we'll always put u above the first bracket. And we call the second part of the function, the second bracket, v. So we're basically letting u equal x plus 3. And we let v equal x squared plus 4. So in other words, we're separating out that product into two parts. Now, if we look at the rule itself here on the top right-hand corner, we can see what we have to do next is we take the two functions, the two separate parts of the function, u, and I multiply it by dv dx. So what that means is I'm multiplying u by the derivative of v, and then I'm adding v times du dx, where du dx means the derivative of u. So this is the product rule. So if we look at u, we're letting u equal x plus 3. So therefore, if I differentiate, I'm saying the rate of change of u with respect to x is equal to, well, if I differentiate x, I just get 1. And if I differentiate 3, I get 0. So remembering from yesterday that the derivative of a constant is always 0. If I then look at v and I differentiate v with respect to x, then I get x squared differentiated is, bring down the power and take 1 away from the power. In other words, I get 2x. And if I differentiate 4, well, I get 0, because the derivative of a constant is always 0. So now I have u, I have du dx, I have v, and I have dv dx. And du dx is basically the letter on the left is u, the letter on the right is x. So you'll see the letter on the left goes on the top, du, and the letter on the right goes on the bottom, dx. So in other words, we're finding the rate of change of u with respect to x, or the rate of change of v with respect to x. Or if we go back to the original function, y equals x plus 3 by x squared minus 4, then what we say is dy dx, the original function, and we're looking at the rate of change of y with respect to x, is equal to, so now I just put in, what do I have for u? Well, I've called u x plus 3. What do I have for dv dx? Well, I've found dv dx to be 2x. v we let equal x squared minus 4, and du dx we found to be 1. So this is my answer, this is my derivative. But of course, in maths we should always tidy up and simplify. So to do that, we're going to multiply out our brackets here. So we have x by 2x is 2x squared. 3 by 2x is 6x, plus x squared minus 4. And I can simplify that one step further because I can add my x squareds, which gives me 3x squared plus 6x minus 4. And therefore that is my derivative. In other words, the slope of the tangent to the function y at any given value for x is 3x squared plus 6x minus 4. So you're always letting the first bracket be u and the second bracket be v, and then going to page 25 in our tables, we can simply apply that rule. So let's have a look at one more example. So here we have find the derivative of root x minus 4 by 2x squared plus 3 plus 6. And I should say y equals. So again, we call our first bracket u and our second bracket v. And we say let u equal root x minus 4 and let v equal 2x cubed plus 6. But before I can differentiate root x minus 4, we have to write it as x to a power. So that's going to be x to the power of a half minus 4. So now if I differentiate u with respect to x, then I bring down the power and I take 1 away from the power. And if I differentiate 4, I get 0. So if we were to tidy that up, that's a half times x to the power of minus a half. So minus means 1 over x to the power of a half. And of course, x to the power of a half is root x. So therefore, that's a half times 1 over root x. So in other words, 1 over 2 root x. If I look at v then, v is equal to 2x cubed plus 6. So if I get dv dx, bring down the power, multiply it by the coefficient. So 3 times 2 is 6. Take 1 away from the power, so 3 minus 1 is 2. And if I differentiate 6, I get 0. So now I have u, v, du dx and dv dx. And we say on page 25 of our maths tables that dy dx is equal to u times dv dx plus v times du dx. So if I sub in my values there, what do I have? Well, u is root x minus 4 times dv dx, which is 6x squared, plus v, which is 2x cubed plus 6, times du dx, which is 1 over 2 root x. And we can, of course, multiply out the brackets there, which would give us 6x squared root x minus 24x squared plus 2x cubed over 2 root x. Sorry, that should be plus 6 on the top there. And that would be our answer, because we cannot tidy that up anymore unless we were to get a lowest common denominator and write it as a single fraction. So sometimes in the exam they might ask for that, but in this case we're just looking for the first derivative. So if we wanted to find the equation of the tangent, we would need to know a value for x. We could sub in then and find our slope and find the equation of the tangent as we have done previously, where we have y minus y1 equals m times x minus x1. Okay, so let's look at rule 3 then, where we're dealing with fractions or quotients. So rule 3 is the quotient rule. It's a bit like the product rule, where we had two functions in terms of x multiplied by each other. The quotient rule comes into play when we have two functions divided by each other. So in other words, two terms or two variables in x, one over the other. So if we look at page 25 on our maths tables, we'll see the quotient rule. And you can see the quotient rule is when we have y equals u over v. So in other words, we have our function on the top and a function on the bottom in terms of x. The top we're going to call u and the bottom we're going to call v. So a bit like the product rule, we're going to start by saying let u equal 2x plus 1 and let v equal x squared minus 5. And then if we look at the quotient rule, we can see that it's dy dx is equal to, and this time it's v times du dx minus u times dv dx all over v squared. So this is the quotient rule. So let's apply that here. So we need du dx and we need dv dx. In other words, u is equal to 2x plus 1. So if I differentiate u with respect to x, well then 2x differentiated is 2. And if I differentiate a constant 1, I will get 0. If I look at v, x squared minus 5, and I differentiate v with respect to x, then bringing down the power gives me 2x. And if I differentiate 5, I get 0. So now I have everything I need to sub into this formula here. So we have dy dx is equal to v, which we said was x squared minus 5, times du dx, which we've found out is 2. Be careful here, it's minus u, which is 2x plus 1, times dv dx, which is 2x. And you can see I'm putting everything in brackets because, again, I always say to you, brackets are your best friend, especially when you have a negative sign there. It's going to stop you from making those mistakes in multiplication. So the bottom of the fraction here now is b squared. So again, we have x squared minus 5, and that's in brackets to be squared. So majority of the time we always leave that as is. We don't simplify the denominator, we only ever simplify the numerator. Because often we can get something on the top that will simplify or cancel with the bottom, which can be quite nice when tidying up. And if not, we just leave it as is. So multiplying out the top line only, we're going to have 2 by x squared there, which is 2x squared, 2 times minus 5, which is minus 10. And again, being careful here with this minus sign. So we have minus 2x by 2x is minus 4x squared. And minus 1 by 2x is going to be minus 2x. And then on the bottom, we have x squared minus 5 to be squared. So tidying up that top line there, we have dy dx is equal to minus 2x squared minus 2x minus 10. And on the bottom, x squared minus 5 to be squared. So our derivative is minus 2x squared minus 2x minus 10 over x squared minus 5 to be squared. In other words, the slope of the tangent to the function at any given value for x is represented by minus 2x squared minus 2x minus 10 over x squared minus 5 to be squared. And if we wanted to evaluate that, we would need to know a value for x, which would be given to us in the question. Okay, so I'm now going to get you to do the questions that I've assigned to you on Teams in class and finishing for homework.